Good morning. This is Sai Krishna. Today I would like to discuss about pile foundations. Before going to study about pile foundations, we need to know about what is meant by a foundation first. Foundation is a substructure which carries a superstructure loads to the subsoil without causing failure. Foundations are subcategorized into two types. First one is shallow foundation. Shallow foundation is defined as a foundation which is having the width is greater than depth. The best examples of shallow foundation are strip, combined foundation, mat or rough foundations respectively. Usually shallow foundations are adopted when the soil surface beneath the structure is strong enough to withstand the superstructure loads. But the deep foundations are employed when the soil strata immediately beneath the structure are not capable of supporting the load with tolerable settlements or adequate safety against shear failure. Deep foundations are defined as when the depth of foundation is greater than the width, it is considered as a deep foundation. So here we can clearly observe the different types of deep foundations. One is pile foundation, second one is pier foundation, third one is well or caisson foundation respectively. Pile is a slender member which is used driven into the ground surface, either cast in situ or driven in situ. Piles are very frequently used nowadays. Piers or caissons or well foundations are very large structures constructed by excavating and they are sunk to the required depth. These are usually permitted to visual the examination of rock or soil which they rest. Piles have been used in the prehistoric times from 59 AD itself. Today, pile foundations are very much common than any other type of deep foundation where the soil conditions are unfavorable. So these are the objectives of our chapter. First, we need to go with requirements of deep foundation. So huge vertical loads if you are going to come from the superstructure, then we can adopt a deep foundation. When the soil beneath the superstructure is weak or not having the sufficient amount of bearing capacity, then we need to adopt a deep foundation. Huge lateral loads are going to act on certain areas of the buildings such as towers or chimneys. On towers or chimneys, we want to expect lateral loads which is nothing but high amount of air or wind pressure is going to act. To resist that wind or air pressure, we need to adopt a deep foundation. To reduce the scar depth, we are going to adopt this deep foundation. Now let us discuss about classifications based on the materials used. First of all, the classification based on the material used is first, if we are going to use wood as the construction material, then it is considered as timber pile, and these timber piles are usually 30 to 40 centimeter in diameter, and this can be designed up to 250 kilonewton capacity. Steel piles, these are usually H piles or rolled H piles or sheet piles. These may carry a load up to 1000 kilonewtons or more. Concrete piles, these are maybe cast in situ or precast piles. Precast piles are reinforced to withstand handling stresses. They require space for casting and storage, more time to curve and heave. Heavy instrumentation setup is required. Composite piles are nothing but combination of steel and concrete or timber and so on. So now let us get back to classification based on installation. So based on installation, we are going to have two types, driven piles or bored piles. Driven piles are nothing but we are going to drive the pile at the required depth or required locality, and driven piles are again two categories, precast members or cast in situ. Precast members are ready-made element which have to be driven by the help of hammer. A cast in situ is nothing but we are going to excavate the ground first, thereafter we incorporate reinforcing elements, then we adopt the concreting works. Next, we're going to discuss about classification based on action. The classification based on action, first one is friction pile, second one is end bearing pile, tension pile, compaction pile, and butter piles. First one, friction pile is used to transfer loads to the depth in a frictional material by means of skin friction along with the surface area of the pile. End bearing pile is used to transfer the load through the pile tip to a suitable bearing stratum passing soft soil or water. Tension piles are used to resist the uplift pressure called as hydrostatic pressure to overcome the overturning moments due to horizontal pressures. Compaction piles are used for the ground movement, not for load carrying capacity. So these are the few uses of pile foundations. Pile foundations are frequently used to carry vertical pressures or vertical compressive loads to resist uplift or tensile forces, to resist horizontal or inclined forces. So these are the best examples you can observe. This is a point bearing resistance or end bearing pile. Here we are going to neglect skin frictional forces which are present. These are considered only in case of soft soils. So friction between soil and pile is neglected here. Only the resistance offered at the pile tip itself we are going to consider it as ultimate bearing capacity of the pile. Whereas getting back to friction pile, so in friction pile we are going to consider only frictional resistance will be considered into account, and we are going to neglect the end bearing resistance of the pile. The pile driving, the operation of forcing the pile into the ground is known as pile driving. The oldest method and most widely used even today is by means of hammer. The equipment used to lift the hammer and allow it to fall to head of the pile is known as pile driver. Piles have been used piles are driven by using hammers like this. You can observe clearly a crane is been there. This has been lifted by a hammer with the help of certain height, and this is our pile. This will be continuously lifted and dropped. Because of this continuous lifting and dropping actions, the pile will be penetrated into the ground surface. So these are the different types of hammers what we are going to observe to drive the pile. First one is drop hammer, second one is single acting hammer, double acting hammer, diesel hammer, and vibratory hammer respectively. So now let us discuss about the methods to determine pile load carrying capacity. The ultimate bearing capacity of the pile is the maximum load that can be carried without failure or excessive settlements on the ground surface. First method we are adopting is static analysis, second one is dynamic analysis, third one is load test on piles, fourth one is penetration test. First, static and dynamic analysis are theoretical approaches, and load test and penetration tests are practical approaches. So let us observe first study about static analysis. The ultimate bearing capacity of the pile is considered by the summation of end bearing resistance and skin friction. That is, the ultimate bearing capacity Q suffix UP is equal to end bearing resistance plus frictional resistance. End bearing resistance can be calculated by QB into AP. Frictional resistance is calculated by Fs into As, where QB is the bearing capacity of the pile at the tip or end. Fs is the unit skin friction of the pile and soil system. AB is the area of the pile at the base. As is the surface area of the pile in contact with soil. Generalized equation we will adopt to calculate ultimate bearing capacity of the pile foundation is CNC plus gamma B and gamma plus QNQ for shallow foundations. If we are adopting pile foundations in sands, C will become 0. Here ultimate bearing capacity in case of square or rectangular foundation is QB into N gamma plus QNQ. If it is circular foundation, 0.3 gamma B N gamma plus QNQ. So finally we can neglect, this is driven piles, we can neglect surcharge pressure Q and Q. For all the practical purposes, ultimate bearing capacity Q into NQ. If it is in clay, we consider C and C plus Q. Where if it is pure corrosive soil, NQ value will be 1, N gamma will be 0 and pi will become 0. Ultimate bearing capacity in clay soils is 9 times C. If it is clay deposits, the unit skin friction can be calculated by using Ca plus sigma into H tan delta. Ca is the adhesion and C is a cohesion between the soil and the pile. Sigma H is the average lateral pressure acting on the soil pile. Delta is the angle of internal friction, wall friction. Sigma H is equal to Ks into Q. Ks is the coefficient of earth pressure. Fs is equal to sigma H into tan delta. Ca will become 0. So delta values for the different types of materials used are as follows. Just you can observe. For wood, it is 0.4. For steel, it can be considered, if it is smooth, 0.2. If it is rusted, 0.4. Now let us discuss about dynamic pile formulas. First one is engineering new record formula. And engineering new record formula has been derived from Wellington in 1886 with the help of drop hammer. The generalized equation to calculate ultimate bearing capacity of the pile is W into H into capital H divided by S plus C, where W is the weight of hammer, H is the height of fall of hammer, and C is a constant. S is equal to final penetration per blow. So here we consider the factor of safety value as 6. We rewrite down the equation as allowable bearing pressure as WH into H divided by 6 times S plus C. If we are going to substitute C value as 2.5, it is considered as single acting hammer. So this is a single acting hammer value. We have substituted the C value as 2.5 and factor of safety as 6. If it is double acting hammer, we are substituting W into H divided by 6 times F plus 0.25. If it is double acting steel hammer, what happens is we are equation W into H plus AP into H divided by 6 times 2.5. So WH is weight of hammer in newtons, A is the effective area of the piston, P is the mean steam pressure, H is the height of fall of hammer in meters, S is equal to final penetration per blow, and QAP is the allowable load pile on the pile.